Okay, today we're doing Module 4, Lesson 11. Tomorrow we'll do Module 4, Lesson 12. And then on Friday you will have your mid-module assessment, which will go from Module 4.1 through 4.12. So we're nearing the end of what's going to be tested on Friday, okay? Today's learning goal is to use the RDW strategy to solve fraction word problems involving addition, subtraction, and multiplication. Let's talk about that for a second. What does RDW stand for, everyone? So we're going to read the problem carefully, we're going to draw a picture to help us, and we're going to write math equations and or words to help us solve them, okay? Now, does it make sense that these word problems have to do with fractions? Have we been spending a lot of time thinking about fractions? Yeah. Okay, so likely it'll involve fractions. And how many math operations are there? 4. Addition, subtraction, multiplication, and division. So let's see what we need to be able to do. Have we learned how to add fractions? Have we learned to subtract fractions? Have we learned to multiply fractions? Have we learned to divide fractions? No. So that's why our word problems today will only deal with addition, subtraction, and multiplication. Okay? Before we talk about the problem of the day, however, I want to clarify something very important that we discussed briefly yesterday. Okay? So as we said, there's 4 math operations. There's this one, there's this one, there's this one, and there's this one. Okay? Go ahead and write those 4 operations into your notebook quickly. What we're going to do is we're going to write the word that we often use when we're writing equations using words that's associated with that. What I mean by that is this sign, it's an addition sign, but we call it the sum of 2 numbers, right? What do we not call it? We do not call it plus. Okay, very good. What about this one over here? We call this one the difference, not what? Minus. Good. Because the sum is a noun. It's a thing. But when you plus something, it doesn't really mean anything. Or when you minus something, it's a verb. I can't say, give me the minus of 5 and 2. That doesn't make any sense. But can I say, give me the difference of 5 and 2? Very good. Okay. What about this next operation? This is a multiplication sign. We call that the, everyone? Product. Not the times. Yeah, thank you. I can't say, please give me the times of 6 and 5. But I can say, please give me the product of 6 and 5. Okay? Especially for my English language learners, this will be very helpful because sometimes you might think, wait, when I'm solving word problems, I don't know what this means. This will tell you what it means. Okay? All right, finally, we haven't talked about this regarding fractions, but we know that this is a division sign, and we call that the quotient, not the divided. Please give me the divided of 6 and 2. No, that doesn't make any sense. Give me the quotient of 6 and 2 makes sense. Okay, so yesterday we wrote this part down in our notebooks, some of us who are taking good notes, but we didn't write this part down. So write this part down, because I saw this in a lot of your exit tickets, and that's not what we're looking for. So by drawing our tape diagram, so far we found out that she used 2/5 and 3/10 of her paint, and so she has 3/10 of her paint left over. She needs to do 14 pints. So is 3/10 of her paint 3/10 of a pint? No. It's 3/10 of how many pints? 20 pints. Oh, so she has 3/10 of 20 pints left over? So how can I do 3/10? How can I find out how many pints that is? 3/10 of 20.
3/10 times 20.
Oh, I could do 3/10 times 20, which is the same as 3 times 20 over 10.
Yep.
And then can I simplify the 10 and the 20, changing it to a 1 and a 2? Yeah. So she has how many pints left over? 6 pints left over. Now she needs 14 pints all together, and she has 6 pints left at home. How many more pints does she need to go by? We have to do 14 pints minus the 6 she already has, which is 8 pints. Could we have drawn another tape diagram to show this last part too? Good. Before we even draw tape diagrams, we have to do the R part, which is read. And part of reading is identifying what the question's asking. and the important information. So take some time right now to underline underline what the question is asking and circle all those important informations. Aditi, what's the question asking?
How much water did they spill altogether on the way down?
Okay. Now when I ask you how much water, do I usually want a measurement or do I want a fraction of a measurement? I usually want a measurement. I'm not saying what fraction did they spill. I'm asking how much water did they lose altogether. Okay? Important distinction. Good. Arun, what important information is there?
So they each carried a 48-ounce bucket.
Okay.
By the time they reached the bottom, Jack's bucket is only 3/4 full.
Okay.
Jill's was only 2/3 full.
Uh-huh.
Jill's was only 1/6 full.
Okay. So let's draw 3 different tape diagrams. Okay, we have Jack, we have Jill, and we have Bill. Okay. So here, I'm going to actually draw it. No, let's draw it our same way. Let's draw a piece of tape for Jack's bucket. And how much water can Jack fill in his bucket altogether? 48 ounces, right? Okay. Now, by the time he reached the bottom, it was only how full? 3/4. So we have to split Jack's bucket into how many equal sections? 4. And we have 2 options. We can either calculate how much water was left, or we can calculate how much water was lost. What should we do?
Lost.
Lost, because the question's asking us. So how many of those units were lost? 3 units were still there, so how many units were lost? 1. So let's mark off that we're trying to find one of them. Okay, very good. Now Jill also had a piece of tape for her bucket. And how much water was in hers altogether? 48 ounces. But hers was split into how many equal units? 3. And 2 of them were full, so how many of them were empty? 1. So how many units are we trying to find for Jill? 1. Okay. And then for Bill, he also had a piece of tape to represent his bucket. And his bucket also held how much water? 48 ounces. And his is split into how many equal sections? 6. 1, 2, 3, 4, 5, 6. And his was only 1/6 full, so how many sections were lost? 5. So count off 5. 1, 2, 3, 4, 5, and draw your question mark. This is how we draw the diagrams for this problem. So if we know that for Jack we're trying to find he spilled 1/4 of his 48 ounces, how can I write that into a math equation? 1/4 times 48, which is the same as 48 over 4, right? Which is the same as what? What's 48 divided by 4? How much? 12 ounces, okay. And then Jill spilled 1/3 of her 48, so is that the same as 1/3 times 48? Is that the same as 48 over 3? Is it?
Yeah.
Because it's going to be 1 times 48 over 3. Is that the same thing as 48 over 3?
Yes.
Okay, and 48/3 is the same as how many holes? 16. Okay, now, Bill spilled 5/6 of his 48. Is that the same as 5/6 times 48? Is that the same thing as 5 times 48 over 6? Can I simplify the 6 and the 48? The 6 becomes 1 and the 48 becomes 8. So how many ounces did he spill? 40 ounces. Now, the question's asking how much water did they spill all together? So how can I find that? I can add the amount Jack spilled, which was 12 ounces, to the amount that Jill spilled, which is 16 ounces, to the amount that Bill spilled, which is 40 ounces. So altogether, 12 plus 16 is 28 ounces, plus 40 is, so altogether they spilled 68 ounces of water. So for your final answer, you would need to put the label and box your final answer. Because sometimes we'll be asked to create a story problem just like this. And it's telling us we need to create a story problem. It needs to have a fish tank in it. It needs to include a fraction. And we can see here, we have a piece of tape where the total is 84. And it's been divided into 1, 2, 3, 4, 5, 6 sections. And we can see that we're trying to find 2/6 of what? 84. So basically, we need to write a story problem that's going to involve finding 2/6 of 84. So take a moment right now and write down a story problem that will have 2/6 of 84 in it.